Hi guys, and welcome to Unit 39. In this unit, I know the recording is made a little before the exam, and this one is going to be available actually after the exam. So Unit 39 is not included in Exam 1. As a matter of fact, also Units 37 and 38 are not. But you guys really need to prepare for the next exam, which is going to be in about 3 to 4 weeks. Anyway, the point being in here is Unit 39 talks about the moon, specifically as another object of the solar system. But we're going to take the ideas we learned from Units 37 and 38, namely on the structure of the Earth, namely how the Earth is treated as one of the planets of the solar system, and how we model that over other objects in the solar system. The biggest issue in terms of the moon is its presence to begin with, the origins of the moon. The fact that when you look at the solar system, the inner planets really do not have moons. The Earth has a moon, and that moon is big. So we really needed to explain that. So there were some theories discussed in detail in this unit that need to explain the presence of the moon, the composition of the moon. When the astronauts went there and brought rocks, it seems like there is a lot of similarity between the rock structure on the moon and that of the Earth, but there is also differences of them. So that should really be accounted for. The other thing is in terms of its revolution around the Earth, basically how long it takes to go around the Earth. So there are some properties for its orbital motion that also needed to explain. At this point, the leading theory is that it has formed when a Mars-sized object immediately after the Earth has formed. So in the orbit where the Earth is, there must have been another object of the size of Mars in the same orbit. And because of their proximity, they collided. That collision explains several things. Among other things is the tilt of the Earth of 23.5 degrees today, but it fluctuates between 22 and 24.5. So that is one thing. The other thing is also explains the fact that the Earth and the Moon share a lot of composition. So that size now has given a name. That Mars-sized object has been given a name, namely Theia. So that is in terms of the origin. As I was saying, this is the best theory that it can explain how the Moon has formed and the fact that the Earth has one. Okay. In terms of the structure of the moon, first of all, on the surface, there are some main features of the moon. I mean, you can see them with the naked eye. So the first thing is those big dark spots that are called mareas. They're not, which is the plural basically of Latin word basically, which means seas. The point being in here, they are really not made out of water, but actually those surfaces were the hot surface basically after a collision with large objects from the solar system during the early bombardment stage and even later on. So those, they impacted the moon with such an intensity that they formed basically an indentation, and that because it was close from the mantle, because of the radioactive decay that heated up and basically melted, and that's basically what we look at. The other thing also, we have craters on the surface of the moon, a lot of them, and because the moon does not have any weathering, as a matter of fact, doesn't have much atmosphere to talk about, what we see right now is all of those impacts that happened in the past, and they superimpose on one another. The biggest one, of course, is the Tycho crater, which can be visible from the Earth, I mean, with the naked eye without aided devices. And then there is the rays that are coming off of those craters, in addition to the kind of basically different geologies on the moon. So this is in terms of the outer structure or the surface. In terms of the inner structure, again, it has a mantle, a very thick mantle. As a matter of fact, it has actually a thicker crust than the Earth. It's about 150 kilometers in depth. And then it has a mantle. It doesn't have any kind of plate tectonics whatsoever. It also has a outer liquid core and an inner solid core, but again, they're a lot smaller than that of the Earth because the moon is a lot smaller than the Earth, and also it lost all of its radioactive, basically, decay to produce the heat necessary to melt the cores as much as the Earth does. So this is in terms of the structure. One of the features actually of the moon is how it's tidally locked with the Earth, in a sense that because of the fact that when it formed from the Earth, so it takes the same amount of time to go around its own axis as it goes around the Earth. That's why we see the same face of the moon from the Earth when we look at it. The moon still has two sides to it, and both of those two sides, they spin around their axis, and there is day and night on the moon. The only exception in here is that the day on the moon takes the same amount of time that it goes around the Earth. So a lunar day is about 28 days or 27.3 days, and the lunar month on Earth is about 27.3 days. So as it spins around its axis, it goes around the Earth at the same time. So the two sides still see the moon. So there is no such a thing as a dark side to the moon. There is always basically the moon spins around its own axis and goes around the Earth. So these are the main topics basically from this unit. Again, I need you guys to read the unit from the book. I also need you to go through. There are a few videos that are included in the discussion, and also there is actually attached also PowerPoints. And please complete all of the assignments before their due dates. If you have any questions, and I know some of you have been reaching out to me for help with the homework, I was more than happy to help them. So if again are struggling with any of the assignments or the homework or the project, please reach out to me so that we can complete these things in time. Another project that is popping up this week is the retrograde motion of Mars. So that also I need to bring that to your attention. I may have to dedicate a whole video on that. So please watch out for it. It's still not due now, it's still due in May. So I will follow up with another discussion of that project. Thank you.